there, it's Kayla from Girl Scouts of Maine. Today on our adventure, we're going to be heading to the coast of Maine to the Darling Marine Center, where I'll be meeting with my friend Professor Mayer, and we'll be talking about how climate change has affected marine life and other things in nature. Stick around and let's see what we can find out.
Well, we're at this place called the Darling Marine Center. It's the marine laboratory for the University of Maine. I've worked here all my life, so I was hired here about 45 years ago, and I've been teaching students of all ages, from little ones to grown-ups, and now I teach retired people. I got into this business because when I was a kid, I was in Boy Scouts at about your age, and what that taught me is that I loved being outside. That was just one of my favorite things. So I learned camping and all the things you learn in scouting. But I also liked chemistry. So back in those days, you could do all kinds of things with chemistry you can't do nowadays. But I had to figure out what I wanted to do when I grew up that would combine outside and chemistry. And so I became a chemical oceanographer, which means that I go out to the ocean and take samples and bring them back to the laboratory and do experiments or do analyses and figure out how the ocean is operating using these chemical tools. And that's been a lot of fun for a lifetime.
So that A-frame in the back's got the cranes and stuff?
Yeah, it's you see the wires for the winch.
Yep.
And you can lift heavy equipment. So somewhere around here, buried in the woods, there's a lot of equipment goes on that thing. It hasn't been brought out onto the dock yet.
Huh.
And so, for example, I take mud cores out in the ocean with that thing. The equipment weighs 2,000 pounds.
Uh-huh.
What I meant to do and I forgot was to get some core tubes that to show you how I do it on the mud flat.
Yeah.
That's the story of my career. I started out on the mud flat and then got onto the boat doing the same thing.
That's cool. Were you anxious to get onto the boat?
No, because I get seasick.
Oh, what? That's interesting. You get seasick, but you're doing this, huh?
Oh, great. Well, thankfully I'm not doing this anymore.
Yeah.
Been there, done that. Thank you.
How did you overcome like getting seasick and knowing that this is?
Pills.
Yeah. Okay.
Which I don't like either. But,
yeah.
But you just have to.
And what's this thing right here?
This is a filter for the seawater pump. So there's a pump that brings the ocean in. The pump is in that brand new little building there.
Uh-huh.
And it pipes it under to the marine lab there, which has a bunch of tanks, so you can bring the ocean into the laboratory and raise animals and plants in there in a controlled environment, which lets you do experiments.
Technology, it's amazing.
Yeah. The theme of the laboratory here is connecting people to the ocean.
Yep, I like it.
Yeah.
That's really cool. And what type of animals would be inside?
Well, because this laboratory helped spawn the aquaculture industry, there's been a lot of shellfish work.
Yep.
So people learned how to grow oysters and clams and scallops and all sorts of shellfish like that.
Yeah.
We have people who do fish work, finfish work. There are people who do squid.
Uh-huh.
There are a lot of people who do the little worms that really make up most of the animals out on the flat.
All right.
In the sediments. The ones who really make the world turn around down there. So all sorts of things.
Yeah.
And that's just the animals. There are algae and bacterial lab.
Yeah.
All sorts of stuff.
We have a lot of animal lover Girl Scout.
we're standing now on a dock, which lets us get down onto the water. So this is a place you can see people have been bringing crabs and other marine life in here and to bring them back to the laboratory. We're standing on the banks of what's called an estuary. An estuary is a place where the rivers meet the ocean. So it's a meeting place of the two kinds of water. And those are very important environments in Maine. Maine has a huge number and variety of estuaries. Estuary comes from the Latin word est, which means tide, water going up and down, and airy, which means place. So an estuary is a place of the tide. So the water goes up and down, and we're standing on a dock that goes up and down with it. And we come down here and we make measurements of the waters in the estuary, or we go diving into the water or take boats off of here. Climate change has made a big difference since I've been here over the 45 years. The big obvious difference is that the water's gotten warmer. The Gulf of Maine has been getting quite warm over the last several tens of years. And so you can almost go swimming here now in the summer. You couldn't when I first got here. Used to be that when I first got here, this estuary would freeze over in the winter. I haven't seen ice in the winter here for 30 years now.
Oh my goodness.
There's an old story in the neighborhood that somebody moved a house from this side of the estuary to that side of the estuary, across this water in the middle of winter. But you couldn't do that anymore. So that's real evidence of some kind of change in the climate going on. And you can see that in the kinds of animals and algae that live in the water too. You're starting to get warmer water species of algae or of animals. One that you maybe hear about in the newspapers is that we're starting to get sharks coming up from the south. And so I was at a beach this winter talking to one of the rangers there, and they were telling me that they're seeing lots of sharks using their, some of the sharks get tagged, they get radio tags when they're down south, and they're finding these tags coming into the waters up here. So there's real evidence that the place it's becoming a different kind of ocean here slowly. And one of our jobs at a marine lab is to show how that happens, to go out and sample what's in the water, what's down on the mud, and document it. The measurement that I do, which is the one most volunteers do, is called a Secchi disc. It's Secchi stands for it's a name for a guy back in the 1800s, an Italian guy, who the Pope wanted him to find how clear the water was, because they needed to know for the ships that are coming into harbors. Yeah. And so they invented it's a plate about 10 inches across or so that is painted black and white. Mm-hmm. You lower it on a rope until you can't see it any longer. Mm-hmm. And then you record that depth. Okay. That depth is about the depth at which phytoplankton can still photosynthesize. Yeah. As you get more phytoplankton in the water becomes murkier, and you've been to ponds that are greenish, yellow, and so forth. Yeah. So it's a great environmental monitoring way of seeing which ponds are going eutrophic or have too many algae in them. Yeah. So what I do is I go out every week or two and monitor that Secchi depth, and record that and send all the data in at the end of the summer. And, and they've got volunteers for just about every lake in Maine. Oh, that's awesome. Who does that. Yeah. And then I do the same thing in my professional life here. I bring students down onto this dock. Yep. We lower these things over the side and other instruments. That's cool. Because you use the same thing in the ocean. This alga is being considered for aquaculture now. People want to raise it both for food and for medicine types of chemicals. And some people are suggesting that if you grow enough of this, you can extract carbon dioxide from the atmosphere. Mm-hmm. So this is a form of solving the climate problem using what's called blue carbon. blue because it grows in the blue ocean, and carbon because the plants are made out of carbon. So it's just like growing forests, which is one of the things that you can do as a scout to help stop climate change, is to go out and plant the tree. So some people are talking about raising these in big beds in the ocean. And in fact, just this week I was working with a student who wants to see if she can find pieces of this kelp in the mud underneath there, and see if the kelp is being buried in the mud of the estuary. So we were talking about chemical ways that she could measure these pieces of kelp in the mud. It's these kelp are full of an element called iodine. So if you ever cut your finger, in the old days, you would go and your parent would put a little tincture of this purple stuff on the cut. That was iodine solution. Well, these algae are full of that iodine compound, which is pretty easy to measure. So if you can measure how much iodine is in the sediments, you're probably getting a good measure of how much of this kelp material is going into the sediments. Well, these are also brown algae, just like the algae we saw out on the dock, except these grow in the intertidal zone. The ones we saw off the dock only grow underwater. These are underwater for a few hours a day, but when the tide is down, like right now, they're exposed. And so the shape of these algae adapts itself to being out in the air, so they don't dry out too badly. And they're very common. They're harvested for various things. You can make ice cream from these things.
Yum. Because of the salt?
No, there's a, well, I hate to give you the chemical term, a polysaccharide.
Okay.
It's like a sugar that's been linked together. And they extract it from these algae, and it's used to give texture to foods. It's used in cosmetics. It's used in ointments, all kinds of things. If you like climbing mountains in Maine, you'll often see in some mountains that on the north side they have a gentle slope like this rock here that we're standing on that has all these glacial scratches. And then on the south side, you notice that there's a very steep little face because the glaciers came over and then they just plucked off rocks. So you can see this in a lot of the mountains in northwest Maine. You can see it down in the Camden Hills at very large scales. And here it is on a very small scale. But again, it's telling us about things that happened when the climate was very different than today. It was a lot colder, cold enough that we had a mile of ice above us, and it shaped this estuary. So all the animals and plants and mud and water, they're all living in a house built by these glaciers and this climate change on a very long time scale. So we see at the bottom of this little 8-foot cliff, we see the brown seaweeds that we saw over by the dock. And then we come onto the dock. There's nothing growing on this dock because it's facing to the southwest where we get a lot of wind. So there are waves that come in here, and it's pretty tough for anything to live with all those waves. But if we turn the camera around to the opposite direction, to the northeast, where the ground is sheltered from the waves, we can start to see the beginning of a salt marsh. And this is what you often find on the edge of an estuary, are these grasses. They're just starting to get green right now. In another month, you'll have grass that's almost a foot high in here. So we're going to look at this marsh as we go farther into the mudflat and see how climate change might be affecting the ability of this marsh to survive. Look across the cove here, you see the tide is starting to come in. If you look carefully, there's a bare patch on the ground, and you may not be able to see it, but I can. There, at the top of that bare patch is reddish. That's a pile of bricks that were left there from a brickyard that existed about 150 years ago, a long time ago. They would take all the trees off and use the trees to burn the clay that they got from the soil, and they made bricks out of them. And let me see if I can find a brick. Here's a brick. Here's one of the bricks that they would have made back in the old days. So they brought those bricks down to the shore, and they had a little wharf, and they would put the bricks on the boat and they would sell them to the towns. These towns were rebuilding because there were all these fires in cities back in those days. The buildings were made out of wood from all the trees that got cut, but wooden houses would burn down in these cities, and the city said, okay, you can rebuild the houses, but you have to make them out of bricks because they don't burn. So there was a great business making and selling bricks here. And they would have a small wharf. If you look in the shadow just to the left of the bare patch, you see what looks like a big log there. That was probably part of a dock that they used to load the bricks onto these boats. Well, you can find remnants of these little docks around the cove, and it's clear that the marsh grew out over these logs. So the marsh, since 150 years ago, we can see evidence that the marsh has grown in and then has started to disappear and erode back for reasons such as maybe sea level, maybe green crabs, maybe other reasons, maybe just the direction of the wind. So there's lots of change occurring here on different time scales, a year, 10 years, 100 years, 1,000 years. And it gets very complicated, but it's a lot of fun to investigate. It's like a mystery story. Who done it? Horseshoe crabs are a fun thing to investigate. If you can get connected to one of the coastal land trust organizations, they sometimes go out and do horseshoe crab surveys. So when the horseshoe crabs are coming into shore, they go out and they count them, and that's something that'd be fun to participate. You get to poke around on these marshes and count horseshoe crabs. And then people in the future will know how common they were. This is unfortunately no longer with us, but it's a pretty shell.
If you've been following our Green Me Up celebration this month, and you've decided to work on the climate action activity track, then we just completed step 2, choice 3, where we took a field trip to a marine center to learn more on how climate change can affect marine life and other things. If you liked this video, or if you want to check out more activities with Girl Scouts of Maine, check out our website at girlscoutsofmaine.org or visit our YouTube channel, Girl Scouts of Maine. Thank you for exploring with me, and as always, happy trails!